Here are some important things to remember before starting. Always follow all shop safety rules. Familiarize yourself with the machine. Use cutting oil for every procedure. End mills can only be used in collets. Write down any measurements you take. To begin milling operations for the beta test piece, measure the two different thicknesses of your part and record these numbers for future use. Clean the vise in parallel with the rag and your hand to remove oil and debris. Next, place your part in the vise, making sure the flat with the hole is against the back of the vise. Give the part a few blows with a rubber mallet to seat the part against the parallel. The parallel shouldn't move under the part if this is done correctly. If the mill is not in high gear, adjust the speed range lever to the correct position. If the lever doesn't lock in place, you could turn the spindle with your hand to get the gears to mesh. Now grab the end mill and place it in the collet, making sure the cutters are completely exposed. Clean the mating surfaces and insert the collet in the spindle so that the groove in the collet matches the key in the spindle. With the quill raised all the way up, press in on the power collet control to thread the collet on the drawbar. With the part directly under the end mill and the quill all the way up, raise the table until the part is a couple inches from the end mill. Now lower the quill until the end mill nearly touches the part and lock the quill in place. Raise the quill stop as high as possible to prevent the end mill from pulling itself into your part, and to give you a reference point if you need to raise the quill. Unlock the quill, raise it up, and bring it back down in the stop to ensure its accuracy. Turn the power switch to forward and set the machine to an appropriate RPM. To find an appropriate RPM, use the RPM calculator on the computer attached to your machine or consult shop staff. Now raise the Z-axis until the end mill comes in contact with your part and forms a chip. After you see a chip fly, enter the thickness of the part corresponding to its current orientation. Never press return absolute 0. Next, unlock and raise the quill, then move the table so the end mill can clear the end of your part. Now raise the table to take a 30 to 40 thousandths cut. Apply cutting oil and make your first pass using the X-axis handle. Cutting from right to left will throw chips towards the back of the machine, which can be a more desirable procedure. Raise the table for a second pass, making sure to leave 10 to 15 thousandths for the final pass. Apply cutting oil and make your second pass. Raise the table until the DRO reads the part's final thickness, apply cutting oil, and complete your first flat. If there's a small ridge left on your part, the end mill is either not wide enough or wasn't centered on the part. Adjust the Y-axis so the end mill can cut the ridge and make another pass at the final height. After turning the mill off, pull the spindle brake lever and raise the quill to remove your part from the vise. Clean the vise in parallel again to ensure accuracy. Note which side the previously drilled hole is on and place your clean part in the vise. You must remember where the hole is so you drill your hole in the correct location. Use the rubber mallet to secure the part in the vise. Repeat the procedures used to machine the first flat to machine the second. When both flats are finished, it's time for the drilling operations. Remove the end mill and collet from the spindle. You will use the drill chuck for all remaining operations, although a collet is also appropriate. Grab the edge finder and secure it in the drill chuck. Use an RPM of around 600 to 800 for the edge finder. You will use the back of the vise to zero the Y-axis. To use the edge finder correctly, it should initially orbit. When it begins to touch the surface, it will become centered. When the edge is found, the finder will become offset. When the edge finder offsets, immediately zero the Y-axis. Now you're not finished yet. Move the table so the edge finder isn't contacting the surface, raise the quill, and compensate for the radius of the edge finder. Re-zero the y-axis to ensure the spindle's axis is directly over the back face of your vise. To zero the x-axis, repeat these steps on the faced end closest to the first hole on your part. Don't forget to compensate for the edge finder's radius. Now that you've found your zero, you can use the part drawing to correctly locate where to drill. Switch the edge finder for the center drill. When you found the correct location, apply oil and peck drill your starter hole. Switch the center drill for the twist drill. Move the table so the drill is over the flat, lower the quill until the tip of the drill touches the flat, and zero the quill travel digital readout. Reposition the table to the correct drilling position and peck drill the hole to the depth needed to tap this hole. Remove the twist drill and replace it with the countersink for the deburring operations. When using the countersink, the RPM should be reduced to between 200 and 300. Apply oil and lightly deburr the hole. Now switch the countersink for the dead center. Grab the tap and secure it in the tap handle. Oil the tap and place its tip in the hole. Lower the quill so the dead center makes contact with the tap handle and begin tapping the hole. Turn the tap 2 to 3 half turns in a clockwise direction to cut threads, then 1 half turn in a counterclockwise direction to break the chip. Repeat this process until you've tapped to the bottom of the hole. If at any time the tap feels too difficult to turn, back the tap out, clear the chips, and try again. Once you've tapped to the correct depth, remove your part from the vise and deburr all sharp edges with the file provided. Congratulations! You've now completed your beta test piece. Clean your workspace, fill out the handout with your parts measurements, and return to the tool crib window. Here are some important things to remember. Use cutting oil for every operation. Write down your measurements. Always clean mating surfaces when changing tooling or holding your material. Use appropriate speeds and feeds. Clean your workspace and return all tools to their proper locations.